So what we're going to do now is we're going to go over in some more detail how assemblies work. So I'm just going to create a new document. Actually, no, I'm going to open up one already had. I'm just going to go back to that original document where I made the gears, and I'm going to mess around in the assembly so we can learn about different mates and how they function. Something that, did they change the name again? They changed the name again, cool. Something that will be a very useful tool for everyone to have. Used to be called CAD, then it used to be called something else. Now it's called FRC Design Insert. That is a plugin that OnShape has, where a whole bunch of teams have uploaded different CAD files of commonly used parts for everyone to have access to. If you want to use it, you want to go up in the top right to the App Store, click on that, and it should open up a new tab. In this new tab, if you search for FRC, why? Probably because I already have it, but there. If you search for FRC Design, because apparently FRC is not good enough, you're going to get this thing called FRC Design App. So again, from somewhere on OnShape, you want to find that App Store in the top right corner, and then in the App Store, search for FRC Design. That will show you the old, what used to be called MKCAD. It'll show you the plugin, and you'll be given the option to subscribe for it. It is free. They will not collect a credit card. You just click subscribe, and it adds it to your OnShape account. But as you can see, this is a library that contains nearly everything that you need to make a robot, outside of custom parts that we have to design ourselves. It is a great tool and one that we use all the time because it would be so much wasted effort to try to CAD this every year. So I'm going to go back to the actual assembly. If you don't get the FRC design on the bottom, or on the middle of your screen on the right, just refresh the page and it should pop up. But I'm going to use that to add a bunch of parts that we're then going to assemble together into something hopefully resembling a functional object. So to start, I'm going to make, I guess, just a basic axle because it'll be sort of simple to add. Alright, I'm going to add a few objects. One of them, I'm going to, since it's the first in here, I'm going to add one of these Versa hubs. When it loads, actually. Something to note is what we use in our team is hex shafts. We don't use round shafts, we use hex shafts. Most of these parts, most of these parts have different options you can choose from round shaft to hex shafts, as well as different diameters. We almost always use a 1/2" hex. Sometimes we use a 1/4" hex if we 3/8 hex if we have the need to. Alright, so what's supposed to happen is you're supposed to be able to search for a part, click on it, and then select insert, and it's supposed to add it into your CAD assembly. But for whatever reason, I don't know if it's my specific computer or if it'll happen to you guys too, it does not want to add anything. So usually you'd be able to click insert and add the part over here. Since that's not working, instead what I'm going to do is up on the top left, there's the regular insert. And by default, it shows me everything else in this document. So you can see all of the different gears from my linear pattern that I did before, as well as the ones that are cut up, and also the whole part studio with the funky shape. So if I wanted to, I can click on that and add it in. And now I have my part from the part studio. Since I only have one, there's not a whole lot for me to do with that. What I can do instead, and what you guys can do, because it's also can also do is if you go to other documents, you can then go into the classroom and see all of the parts that we've made in the past however many years we've had a classroom, 2 or 3 years now. So if I wanted to, I can go into our sibling and find, oh wait, sibling doesn't have it yet. I can go into our competition robot and find pretty much anything I want to find that we have there. So for example, let me grab one of the main bot wheels. So this is one of the wheels that we used on our shooter, but I can just drag this into my file and now I have the wheel. Alright, I'm just going to drop the entire shooter in here now for this one. Alright, I'm going to start this from scratch because it'll be faster. Okay, when you're messing with an assembly, what you need to do is you need to add a bunch of parts in it so that you have something that you can attach together. So, for example, if I just throw some of your related here. Alright, so I just throw some of the parts in here. Let's say that I want to fix this gear onto this shaft over here. Right? I know there's no hole, it's okay for now. If I want to attach these two together, I need to use a mate. Mates are 3-dimensional constraints that give you select 2 points to mate together and then you give them a set of rules that they have to follow. So to start out with the simple ones, the simplest one is you have a mate connector. This is not a mate. This is a way to add a selectable point onto an object if, for whatever reason, the normal selection points aren't working for you. So I can add a mate connector onto here just to make it easier to select. But I don't have to. I can also just select the center point if I want to. This is just a way to make it a little more streamlined. So I'm going to put a mate connector on here. Now I want to stick this gear onto this X shaft. I have a few different options to do that. Fascinate, Revolute, slider, planar, cylindrical, There's a bunch of different options, right? Anything that's got arrows on it where the fastener mate is a type of mate, they all behave differently, but they all function the same way in that they're joining 2 parts together. You can even change the type after you select it. So if I pick fastener, I can still change it. So like, hey, instead of fasten mate, I want to do a slider mate. And it'll change the rules to make it follow that. But if I want to start and say, I want to fasten mate, which means I want these 2 parts to touch and not move, like they're going to be locked together, then I would select fasten, and for my mate connectors, I would say the one that I just added, and then I want it to be on the center, I want to be centered on this axle. So as you can see, as I hover over, it's got a whole bunch of different things it's selecting, but none of them are the center. So I got to figure out how to select the center point of this thing. So from there, you see as I hover over it, I'm basically just going to the end of it, saying, hey, if I get close enough to the end, it should give me one right in the center like that. Because it tries to guess what you're trying to pick. Typically the midpoint of something or the center point of something is what people select, so it'll attempt to highlight that for you. But if I just click on that, it'll automatically try to stick them together following the rules that the fastener mate has. So you can see it stuck them together on my mate connector and the center of that axle. Now, I'm a little off, right? I'm inside of this bolt because that's what it wound up selecting, which means I gotta move it inside of that. There's different rules that you can set that it has to follow, one of which is offset. If I say I want to offset it, and it tells me what the 3 directions are, right? You can see Z is this blue one here, X is the red, Y is the green. If I want to push it further onto the axle, that means I need to change the Z axis. So I just come up to the Z offset and I say 0.1. This is going to be kind of small material. But you see, it moved it the wrong way, right? It moved it off of the axle. I want to go the other way. So I need to make this negative. If I make it negative, it pushes it in the correct direction. So now, if I zoom in, you can see the fasteners now, or the mates now put it on the axle instead of on the screw. This is good. This is where I would like it to be. So I can hit done and it'll save it. And now if I try to move this here, it's not going anywhere. It's stuck on the axle. Everything else is moving around it, but that won't move. And those are now fastened together. If I want to say, because this is actually supposed to spin, I would prefer this to be a Revolute mate, right? Something that allows it to rotate on the axle. Because in real life, it should be spinning. You can make this a new fastener if you want, or what is far easier. Yeah. I can just go into the one I already have and change it to Revolute. You'll think for a second. Excuse me. Now that I've changed it to a Revolute mate, if I save that and I try to move it, the gear now spins, right? It still doesn't move from where I attached it, but Revolute says it's allowed to rotate, so it lets it rotate along that point. You get a few other options you can do. One of the ones that's fun that we'll probably end up using a lot is the slider mate. So the slider mate, it's instead of letting it rotate around the point, it lets it slide up and down the point. So if you have an elevator, slider mate is good because it'll let you set it so that if you click and drag, the elevator will actually move. And you set limitations on how far in either direction you can go. So I can do the exact same thing. I would say on this mate connector, I want to add this gear, right? So I'll select the center of this gear, and I want to connect it to this side of the axle. So I'll go over here and I'll mess around with it until I get the one I want. There we go. So I want to attach the slider mate there. And now, if I want to mess with it, it'll be locked in place, but now I can slide it along that axis, right? I can slide it wherever I want. Right now, there are no limits. Obviously, there should be, because the axle is only so long. So if I come in and edit it, you get limits on a lot of these mates. You don't get it on fasteners, because fasteners don't move, but you get it on pretty much anything else. The limiters let you set maximum and minimum for the range of motion. For this one, we can say the minimum is Z is going in this direction. So our minimum can be 0, meaning it will stop here, and the maximum will say for now 5, just to see how far it goes. If you want to test it, you can click the little play button, and it will slide all the way from limit 1 to limit 2. As you can see, numbers are a little wonky with that because it's letting me go away from it. Or it's not, it just wanted to be different. Okay. So now it lets me slide about halfway down. If you want to be accurate about it, you would go measure your actual length and set that as your limits. Since I'm just picking and pulling numbers out of thin air here, you can see it's not quite the case. But now I have a slider made, so if I want to move it, it now slides up and down. So parallel mate is, we're basically adding a degree of freedom each time, right? Revolute mate lets you spin around a point. Slider mate lets you slide up and down an axis. Planar mate means you can slide left to right, front and back, as long as you stay on that plane. That usually winds up just being beneficial to work in conjunction with other mates to constrain it properly. On its own, planar mate is almost always too loose of a definition to actually be usable. But if you combine that with, say, a slider mate, or combine that with like a pin and slot mate to give it restrictions of how far it's allowed to move, then it lets you set up a combination of mates that constrain it to the specific range of motion you want. So this one's more of a modifier than one you use just explicitly on a plane. But it works, everything works functionally the same way, right? I can say, let's make face of this gear and then the face of this gear to now, something that I haven't touched on yet with the mates is all of them give you the option to invert your direction. So right now these are mated touching each other. If I click this, they're now mated inside of each other, right? It just mirrors your axis. You also get rotate, which will not show you much because this is a round object. But if you have, say, a stick or something that you're mating onto it, and you have it, you want to attach point to point, but for whatever reason your mate's got it turned sideways, that rotation will let you rotate which way the mate faces so that it can actually line up the way you want. These are basically just ways of adjusting the angle of attachment. Right. And then planar mate also has limits. You can limit quite a bit more, right? Because you have three different axes of movement. I'm not sure why it gives you the Z because you can't move along the Z axis, but whatever, I guess that's not important. So just about set limits, I can slide it anywhere around. No, that's fine. Well, I'm ready to move it. Oh, okay, I clicked the wrong one. I meant to click planar mate, not parallel mate. Parallel mate, as the name implies, means they have to stay parallel to each other. Planar mate, which is what I actually wanted, is the one where they have to stay on the same plane of contact. Now you have much fewer limits because it has actual restrictions on it. So now it'll slide anywhere along this X and Y, but it'll never cross the Z plane. It'll never go into that gear. It'll push the gear away instead, right? So now it's allowed to move up and down because we have a slide made on the other one. So these can move relative to each other now on that axis, but they will never cross over each other. So that's what I was meaning when I was saying you can combine these mates together to make the motion you want. You can put two slider mates on too. So that, let's do that real quick actually. Let's change the planar mate to the slider mate to show you what I'm meaning. So now I should be able to get both of these to move. Flip direction. So now you'll see I've increased the range of motion they have because they can both now move 5 inches relative to each other. So we use this a lot when we have multi-stage elevators, right? We have a fixed part of the elevator that you can go up, and then once that hits the limit, the next stage goes up even further. You can use those to build on for multi-stage elevators, anything that's multi-stage really. Let's see. I'm kind of running. I've been talking for a while. Does anyone have questions on mates? Like how specific one works, what we would use different ones for, what any of this has to do with robotics. All right, cool. So I think it's a good place to call it here. I imagine most of you are looking to stretch your legs and get some food.